Hello, how are you? Good, thanks. I hope you're good. Yes, today we are focusing on parabola function. We're starting with functions and we'll focus on parabola. We've been doing parabola since grade 10, and so far I'm sure you know a couple of things, but we just emphasize just for the sake of all of us understanding. Yes, a function of a parabola can be f, okay? A parabola can be f at x is equals to ax squared plus bx plus c, or it can plus c, or it can be in a form f at x is equals to a into x minus p all squared plus q. All right, so the most important thing is to know between these two, you can multiply, you can what expand this or simplify this you to lead you to that, or you can move from here to this form by using the complete the square method. I'm just going to show you, but now the important part now is just to know the turning point, how to identify the turning point, right? In this form, identifying the turning point, you get your x value of turning point TP, x value of turning point, by using the formula minus b over 2a. Where does b and a come from? Here is your a, here is your b. You substitute here and get your x value of turning point. Then for the y, you take the very same x, you substitute in the whole thing, in the whole equation to get your y. Then we're going to substitute where you see your x, you're going to substitute the x value calculated of turning point and get the y. Then this 2 will be your turning point for this equation. And then for the bottom one, when you're looking for turning point, what happens is that your p will be your x value of turning point, and your y, and then your q will be the y value of turning point. And the catch here is to remember the p. Remember, the formula has minus. You take p, a positive p, you omit the negative sign. Therefore, if here it's like x, let's say you have x plus 4 all squared plus 2. In this example, where this is your equation, meaning your a is 1, in this example your turning point for this graph will be minus 4. Why? Because we know minus 4 and this negative of the equation makes positive 4 here, and then q, you just take it as positive q. Here it's 2. And then if it happens, let's say it happens here, that it's minus, then even your 2 here will be minus, because this negative times this positive give us this minus. So I hope everybody understand the idea here, and that's about it. From here, then you're gonna, after getting the turning point, you're gonna get the x-intercept. I hope everybody knows how to get x-intercept. The x-intercept, that's where you let y is equals to 0 and solve for x. And then your y-intercept as well, you add where you see x equals to 0 and solve for x. In this case, remember, if this is 0 and this is 0, then your y-intercept is just going to be c. In this case, it's a little bit different, because if you let your x is 0, this still becomes a value, but it will all equals to c. We'll see it with time as we do this example, right? Then we proceed. Let's say we're given a function of a parabola y is equals to x squared plus 5x plus 4. Yes, meaning you see it's 4, your b here it's plus 5, and then your a it's 1. right? Meaning we're given the first form. Now we want to take the first form and move to the second form. We do it by completing the square. How do we do it? We just say y is equals to x squared plus 5x. When we complete the square, we take the coefficient of x and then divide it by 2, and then all multiply or all to squared, right? But remember, it wasn't there. Then we take it out again because it wasn't there. It's something new. So that this minus that is equals to 0. But we're not going to minus now. And then what's left is plus 4 at the end. Don't forget the plus 4. Then from this case, we know that this complete the square. We did complete the square while we were doing the other video. I forgot the video. It was on yeah, but we completed the square. Then let's see. Then we take the first one and this other one, because they're both square. We're just gonna use the sign here. It's plus 5 over 2, because 5 over 2 is 2.5, but we just write it as 5 over 2. That all squared. Then if you expand this, it's going to give you this, the underlying value above. Then from there we add this, since they are the remaining out like terms, and then it gives us sorry, 9 over 4. Then this is it. You are done. You have moved from the first form to the second form. Now you can see that this is your P, this is your Q, and here it's plus, and then the value of turning point in this form is going to be your P. It's negative 5 over 2. So that negative and the negative of the equation gives you this positive. And then Q, I've just explained. This negative times positive gives you this negative. So these are the turning points of this function using the second form, right? Let's use the first form and see. In the first form, it's just going to give us, it's coming here, right? In the first form, it's coming here. And then we know that our x of turning point would be minus, what's our b? Our b is 5, minus of the equation here, then it's 5 into 2. What's our a? A here it's 1. Then we're just gonna have 1. Then it gives us negative 5 over 2. You see this x is equals to this x, they are the same. Then looking for y, turning point, as I explained here, you take your x and substitute in the function, then you substitute in here, whereby we are having minus 5 over 2 all squared plus 5 into the same x, which is minus 5 over 2. There's no squared plus 4, right? Using your calculator, this is 25 over 4 plus minus 25 over 4 over minus 25, not over 4, over 2 plus 4. Then it ends up giving you negative 9 over 4 using your calculator, because this I like terms. Then you see your x is equals to your x turning point, your y is equals to your y turning point. You can use both of this the way I told you which one, any one of the two, provided that they give you which form, because the form gives you the opportunity to use any and save your time. You can't be converting while you can just get it directly. Yes, so that's most about it. And then the x, while we're looking for the x intercept, we're just gonna, you see it says when you're looking for x-intercept, you let y is equals to 0. Then you're gonna go through this form and say, well, our y0 is equals to x squared plus 5x plus 4. But we are looking for the x's. This is 0, not 6. Then from here, since it's 0, then we have the privilege of factorizing. Remember, I told you that when it's 0, you just factorize the x squared, xx, 4 values. Factors of 4 is 1, 2, and 4, which will give 4 times 1 is 4, 1 plus 4 is 5. Then you're going to use 4 and 1 plus and plus. Therefore, we end up having our x is equals to -1, or our x is equals to -4. Then we know we have the coordinates of x-intercept where it's -1 and 0, because they told us here y is always 0, and then as well -4 and 0. Those are our x-intercept. Our y-intercept, we put x we let the x be equals to 0. Then we go to the original function and say we're looking for y equal to 0 squared plus 5 times 0 plus 4. 0 squared is 0. Any number times 0 is 0. So 5 times 0 is 0. Then we're only left with 4. Remember I told you our y-intercept is just c. There we got our y-intercept. Then our we only have one y-intercept. We know that x is 0, and our y will just be this 4. Happy? Any question until this point? Still waiting. Oh, if no question, then I can roughly explain the line of symmetry. It's very important. The line of symmetry on your parabola, these are your parabola, meaning here it's positive, it's happy parabola. Whenever you see a parabola that goes like this, you just know that this a here is positive, or this a is positive. But whenever it's sad, you see now it's pulling a sad mouth, you know that your a is what? Negative. It's guided by the sign of this ace, right? And then the line of symmetry simply means it's a line drawn from the turning point downwards. Remember, this is the turning point, what we have been calculating here and here, right? Yes, and as well here, the line that cuts us straight on the turning point. Never mind my speed, right? Right, and then as it cuts at the turning point, it simply means the distance from this side to here. Ouch. The distance, let me use a different color. The distance from this side to here will be equal to the distance from this side to there. Even here, if you are here, distance from this to there will be equal to distance from here. Even here will be equal. That's what the line of symmetry does. It cuts the parabola into two. So this portion, this right portion, will be equivalent to this left portion if we're calculating the areas. That's what line of symmetry means. Same in here. That's what line of. Then let's elaborate further. Let's say this is your x line, your x-axis, and we know that your x turning point is 0. X, this is your y. Then it cuts at 0, and here it's 2 on your x-axis, meaning from 0 to 2 the distance is 2 units. It simply means on the other side you can get it by saying it's -2, because negative in the negative direction, but the distance from 0 to -2 is still 2. You see, the distance are equal, right? In this case, that's what it all means. So if we know that from, let's use a different color. If we know from here to there, maybe it goes down here and it tells us it's 3 straight, right? It means from here to there as well it's going to be 3. Then here this coordinate is going to be -3. Then we have this corner, provided we know the y. I hope I'm making sense in all this, and we are all good and understand. Thank you for watching. Looking forward to see you on the next video.